All right, hello and welcome to the February 17th SIG Auth. Let me present my screen. All right. So to kick things off, just an announcement about the pod security policy breakout session. For now, we're going to keep the same time as our recurring meeting. That's Wednesdays, 1 to 2 p.m. on the SIG Auth off week. So not today, but next week we'll have the next one of those sessions. And for now, we're going to try and limit pod security policy discussion to that breakout session, just to be fair to folks who are able to make that meeting. We don't want to fracture that conversation. So we won't be talking about pod security policy today, except where relevant to other things, such as ephemeral containers. All right, so first on the list of discussion topics, this was carried over from last week. Sorry, we didn't have time to get to it. Rian, if I'm pronouncing that right, do you want to take the mic?
I think I'll leave that to Hippie or Stephen, because they're more. Stephen, do you want to explain the issue?
The hidden options verbs, when they're getting passed through a proxy server, they're having a bit of misalignment or slash not being detected, and Hippie has done a number of messages on the mailing list around it. So, Hippie, do you want to have a follow-up?
Sure. We've got an issue where we've been discussing it, and we also sent out to the mailing list on the 4th of Feb. But the short of it is the head HTTP option gets turned into a GET, and that's due to some of the auditing mechanisms in place within the API. And another one is that the options gets completely dropped, and that makes it very difficult to understand via our auditing mechanisms which operation IDs for these particular ones. When we hit head and option, it makes us it overlaps, because the open API definition, in order to map it, we need to look at a path and we need to look at the HTTP verb, and our auditing has a field for the Kate's verb, but it's again, for these two options, it's not available there. It gets changed and dropped within the audit mechanisms, and sorry, the auth mechanisms. So the conformance group underneath SIG architecture, we really depend on these audit logs to be accurate and to be able to map them back to the endpoints that are being hit. And I'm under the impression that this is due to transformations governed by SIG Auth. I just want to confirm that and get some guidance there.
So the parsing of request info from an incoming request is half SIG Auth and half SIG API machinery. Both of those groups use that information. SIG Auth uses it for authorization and for audit. SIG API machinery uses it for routing and admission and things like that. I had commented on the issue. So mapping audit events back to the open API spec is not really an explicit goal of the audit log. There are other dimensions that are also surfaced in the open API spec that are not included in audit, like all of the except parameters for the encoding that is returned to the user, right? So the user could request JSON or YAML or protobuf encodings, and like that's listed in the Open API spec saying we can produce these things, but I don't think that gets included in the audit log. So before we go too much further down the road, I think like settling that question is a good one to start with. Like, where are the gaps around this verb? Is it just for the proxy sub-resource endpoints? Because those are exceptional in sort of a lot of ways. And so I don't want to deep dive too far if it's really just one special case sub-resource.
Stephen and Rian, if you can back me up on my assumptions here from hearing you, but I do think that these are outliers and do behave differently. And if we want to try to make some workarounds on our side for these, we can take a look at that. Have you seen anything to the contrary of that, Stephen?
As far as I'm aware, the head and options only apply to proxy endpoints. So I think it's actually just an outlier.
Do we know what happens if you send head or options requests to other Kubernetes API endpoints?
I haven't tried testing any of those scenarios because they haven't been a specific option that I've seen in this spec.
Okay.
I think if we search through the Open API spec, head and options is only exported for these endpoints. So I wouldn't expect the API server to respond with a valid routing based on that, but that may not be true. I don't know how the routing occurs, but
okay.
Based on its exported spec, I'd say it should get a 404 or something.
I just tried it. It looks like head does work and options does not. So head is defined by spec to, it should return the same as a get, just with headers. So that actually seems reasonable.
Sure.
If we don't anticipate adding options support broadly, and I don't think we do, then I would recommend seeing what you can do to special case distinguishing the requests. Maybe by adding. Go ahead.
Our current workaround is for these specific tests. We look for the E2E HTTP user agent to match the test that's excluded, and then we also look at the end of the form of the path to include the specific verb, which should help us to match those. I think if we have an empty Kubernetes verb, then we map that to options because that doesn't flow through. So those are our two exceptions. For head, we look at the test name and we look at the end of the path having the all capitals head, because that's what our test actually retrieves. And then for options, we, if it's not in the audit logs, we assume that it's options.
Yeah, I think looking at the path, like putting something in the path that you can recognize on the other end in the audit log is a reasonable workaround.
Okay.
If that unblocks you, I think that's a good approach for you. For the auth folks, I think it's weird for something with an empty verb to show up in the audit log. So that doesn't seem right.
It's an empty string, so it is sent.
I wouldn't try to disentangle the head and get collapsing to get. That seems okay. Does anyone have thoughts on what we should do with other verbs that show up other HTTP methods that show up, so that we don't stick empty data into the audit log.
What gets passed to the authorizer in that case?
If request info is empty, then I would guess that the verb in the authorization request is also empty.
That also seems bad.
Yes. Although
You can assign R back to empty string, right, as the verb. Like,
you can.
It's a valid construct. It's not a good idea, probably.
It's weird. I would guess that any authorization policy that's allowing it is only allowing it because it's allowing star.
Yeah, willing to bet that.
So I would probably decouple the issues, like the head get to get, collapsing to get, I think is working as intended. The other unknown HTTP methods showing up as empty in authorization and audit is probably not working as expected, and we can discuss what to do to fix that probably in the issue. How does that sound?
Sounds great. Thanks for putting eyes on this and giving us some clarity and direction on it.
Yep, I'll summarize and circle back to the issue on that.
Excellent. Thanks, Jordan.
Thank you.
Jordan, do you want us to continue with this on the same issue, or you comment and close and create a new issue for the empty string?
I will probably keep this for resolving the empty verb.
Okay, thank you.
All right. Next up on the agenda, we have ephemeral containers. Who's Lee Verb able to make it? Yes.
Yeah, I was able to make it.
Great, thanks. For context for everyone else, this came up when this came up while we were discussing some options around the pod security policy replacement and asking kind of what the expectations are for handling ephemeral containers, especially in the context of policy exceptions, since the general expectation of ephemeral debug containers, especially with the change to add security context in 121, is that it may be desirable to run a pod with least privileges for production use, and then be able to have elevated privileges in a debug container. So for example, you might forbid capnet raw in a production container that doesn't need it to limit attack surface, but capnet raw is a common requirement for certain types of network debugging, such as ping and traceroute. So that's the motivation for adding security context in 121. Now, when it comes to admission and pod security policy type constraints on these, I believe the way it currently works, maybe someone can correct me if I'm wrong, but I think that so ephemeral containers are edited through the ephemeral containers sub-resource on the pod. And so that generates an admission request, which I think is a list of ephemeral containers. It doesn't have the full pod spec on that, which is a problem for enforcing, for instance, pod security policy. If you want to say, user so-and-so is not allowed to run a pod or container with host network, you don't actually have that information unless you're able to see the original pod. So an admission controller can always fetch the pod directly, but that's a lot more complicated since the admission request doesn't have the full context in it. So the question here is sort of, ephemeral containers are currently alpha, targeting beta in 121. Should we consider changing the admission API or interface for them before they go to beta? Jordan or Lee, do you have anything to add?
No, just that was all correct. Maybe just the added context is back in the way back when we designed this. We were planning on using pod security policy to provide some knobs for tuning here. It's clearly not the way forward anymore, and I'm not sure the right thing to do in its place. And then yeah, that we were planning on going to beta this release, and I think anything as big as changing how admission control works means that we should not go to beta.
Yeah, I actually kind of ran across this by happenstance as I was playing around with different admission stuff and realized that if all you have at admission time is the container, which is the current API of Ephemeral Container sub-resource addition, you don't actually have enough information to know if the container is locked down, because if the top level pod security context was locked down, then it inherits that restriction. If it's not, then you don't know. I mean, one sort of end run around the issue is to say, like, the ephemeral container has to explicitly be locked down. So regardless of what the top level pod said, maybe the top level pod security context already said allow privilege escalation false and run as non-root and whatever else. But the ephemeral one has to do it too. Like, it has to explicitly set these fields. Like, that's actually maybe not terrible. Like, if you think about the use case of someone using an ephemeral container, it's generally orthogonal to the definition of the pod. It's sort of its own thing. Like, I'm going to inject a tools container or debug container. So maybe it would be okay to say admission should expect the containers, the ephemeral containers, to explicitly be setting their run as user or their allow privilege escalation or whatever those things are. But something that is trying to make the ephemeral containers match something about the pod is going to have a really hard time of it. They're going to have to do this out of band lookup of the existing pod given with the current API. So I'm curious what other people's sort of expectations for what sort of checks they would do and what they would want to inspect or change or enforce on ephemeral containers, and whether having to look up the existing pod out of band would be problematic for them.
A good example might be runtime class, which is only specified on the pod. So if I want to say that ephemeral containers are totally unrestricted in a Kata containers pod.
That is an excellent example, Tim.
So I was going to ask at the, just like, if we look at just like the status sub-resource example, like, you have when you ask for status, you get the whole object, right? Not just the status, right? Why would this be any different? Right, because our sub-resources for the most part are just controlled views into, I mean, not, I guess proxy and stuff is magical, but a lot of them are controlled views into the whole object with particular validation or other stuff to give you a constrained API. But even like status being the canonical one, I get the whole object, right? I would expect the whole object in this one.
Yeah, so I mean, that was actually one of the big questions around the original design. Like, do we make it echo the whole pod and then put lots and lots and lots of boundaries around like which field you're allowed to touch? Like, basically ignore everything you submit except this one list. And because you can't remove ephemeral containers, actually require the list to contain everything that's already there and only honor additions. And that just seemed like a really awkward API. The sub-resources that we have in other places where we severely constrain what you can submit, we actually have dedicated APIs. So the examples I can think of are scale and pod binding. So those are the ones where we're basically saying you can only touch one field on the object. And there we don't make you echo the whole object and then ignore everything but that one field. We let you have a dedicated scale or binding object. So that's why we went this way. It's like, oh, it's an append only API. Well, then just give us the containers you want to append. Awesome. But the enforcement context, we didn't fully think through that.
I mean, sorry, I was just going to say, does the input from the user have to perfectly match what admission is then presented with? In the sense of, even if the user is adding just items to this list, append only, must we then turn around to admission? Like, because we could tell admission, here's a pod update. Look, here's the whole pod. Here's the thing you just added. You good with that?
So funny story. There was actually an admission bug around the feature. Admission really expects the type that it's handed to match the type of the request. Like if I register an admission plugin for the pod, Ephemeral Containers sub-resource, I really expect the object and old object that's given to me in admission to be what was submitted to that endpoint. And it wasn't. There was actually a bug around that, and there was like a serialization error that got caught and fixed. So if we're going to change what admission sees, like nothing else in the API mismatches what is submitted to the endpoint and what is given to admission. So it'd be weird to do that here.
Wild idea, but what if we added a sort of like context, additional context to the admission API? So, you know, the main type in the request is still the same, but I also get in this additional list of context things, the full pod. I could also see that being very useful for providing the namespace object for namespace things.
Wouldn't we have to go like change admission webhooks and like the admission review API and like?
Yeah, it's a big change.
David, you're on the call. What do you think?
I would not choose to change. I like the contract of what you give is what goes to admission.
I'm trying to take notes at the same time. If other people want to contribute so we capture some of this, that'd be helpful.
So one thing that's different about ephemeral containers is that we do have additional fields available that's above what's in container. So for example, we added a field to allow namespace targeting, and then we could allow a field if it helped us here. We could add a new field to ephemeral containers itself. We don't have a requirement to. We don't necessarily need to make the entire security context configurable, right? So far, people really just want capabilities. They want to be able to trace things or ping things.
Yeah, but even those are exactly the type of thing that some of the policy levels we have opinions about, right?
Okay.
So like adding non-default capabilities is explicitly part of the baseline and restricted pod security standards. And like Tim pointed out, like that might be okay depending on the runtime, or it might not depending on the runtime. So I would hesitate to sort of special case pod level fields like runtime or security context on the assumption that and sort of shoehorn them into peer fields that we put into ephemeral containers just to communicate down to admission. I'm trying to remember, Lee, long ago, did you look at sending the whole pod to the sub-resource, or did we discuss it and decide on this approach before you started prototyping stuff?
No, I actually prototyped it based on status. So the first version used the entire pod, and then we decided to change it to look more like binding,
Yeah,
or scale.
Another possibility is that there's actually an existing issue around rights to sub-resources not being seen by admission plugins that only have opinions about the whole pod, or only have opinions about the whole resource. And the example was scaling, I think. Like if I want to scale something from 1 to 2, an admission plugin that is only intercepting the scale sub-resource might not have the context it needs to make its decision. And so it's actually a very similar issue to this. So maybe it would say, you can't scale this to 2 because the resources you're requesting, like you exceed your resource allocation or whatever. But the scale sub-resource doesn't have all of the other stuff in the main object. So it would have to do this side channel lookup. One of the proposed solutions there is to let admission on the top level resource be sent the update that would result as part of a sub-resource right. That is very early in the proposal stage. That is nowhere near complete, but it seems like the same category of problem.
So Jordan, I'm not familiar with that proposal, but that would break the contract of admission today, right? That the object that admission sees is not necessarily the object that the user submitted?
So it's a secondary step. So I make a status update to pod status, and I'm writing, or sorry, pod's ephemeral containers, and I'm send some ephemeral containers, and it passes through the ephemeral containers admission plugins, and they all say thumbs up. Well, under the covers, like the pod itself is actually being updated, and so it conceptually could then give the old and new pod to admission plugins that wanted to see all updates to pods no matter the source, and say like an update to a pod is going to be made, and here's the old one and here's the new one, what do you think? And those admission plugins could see updates to pods whether they came through the spec or the status or the binding or ephemeral containers, or I guess pods don't have scale, but like I said, it's identifying a gap, and it's an early proposal, and there's weird like ordering details to work out, and it would have to be opt-in. It would have to be something an admission plugin would have to say, I want to see all updates to this no matter the source, instead of routing sub-resource updates to existing admission. I hesitate to come up with a specific solution to this issue if there's a more general problem being considered. I think the two options we have here are, one, change the API to pass the whole pod. So we sidestep it and say, well, the ephemeral container API is, here's the whole pod, and we ignore everything but this list. That's one possibility. The second possibility is admission plugins who need the context of the pod do an out-of-band get, which is kind of gross, but would probably work okay. Ephemeral containers are probably not a high frequency write, And if you do a get, that's probably good enough. It is gross.
So I'm thinking through that though, like if you use something like OPA today, there's like no way to write like a Rego policy, right?
That's true.
You have to cache all of the pods in OPA.
No, I thought infrequent you could just do. Oh, you're saying that's the way open implementation is?
Yeah.
Okay, I was gonna say a live get for an infrequent write is.
Yeah, no, I was like, I don't know how to express this in Rego in a way, but yeah. So Tim said you could presumably have all pods cached and then look up in that cache in your Rego policy somehow. I'm not that good at Rego, so.
Yeah, that would work. Like today, you could cache all the namespaces.
Yeah.
This is how you get around the namespace.
I'm not sure if it's safe though, right? Because you still have like a delayed view of the world.
Pods are mostly immutable.
That's fair. That's fair.
Yeah, admission gets to see the old object and is called inside the update loop. So if you did a get and the resource version you got didn't match the old resource version, then you would know it was stale.
That still sounds really awful to write.
Yes. I like none of our options. Well, that was a meeting killer.
I tend to think that the just using the entire pod is both the most realistic and I don't know, it is a cleaner API considering the amount of changes that ephemeral containers make.
I mean, it's easier.
It's a big change.
Implementer, but I wasn't going to ask for a significant change on a feature I didn't help.
If you can still patch to that endpoint, then from a client perspective, submitting a patch that can you append? You can't set or append in a patch. That's really unfortunate. I was going to say, if you could submit something that says, like, add this, I want to run this container, like, add this container to the end of the ephemeral containers list. That would be the ideal scenario as a client, because you could get what you have today, where it's like, I don't actually care what's there. I just want to run this thing, like, tack this onto the end and run it. But patch can't express set this to a single item list if the list isn't present, or append this item to the end of the list. So you'd have to do a get, write, put, or get, transform, put.
Can we just default the list to an empty list instead of nil?
I don't know. Maybe. I don't know.
Okay, it sounds like for next steps.
I'm sorry, I have one more question. If we decide to do a big API change, like changing the kind that we're using, is this a thing? Do we want to completely halt ephemeral containers, go back and rewrite it, and then proceed forward to beta again? Or is this a thing that we would want to do in a new sub resource that has a slightly different API and deprecate the old one?
If you start returning a different type from, does the current type support get?
Yes.
It does. Okay. Yeah, if you start returning a different type from an existing sub-resource, you'll break existing clients. Those clients were using an alpha feature.
We've avoided breaking entire deserialization paths in the past, but this one
We
is. I could be convinced this was a sub-resource, and maybe we could find some leeway there, but like that's why we can't reuse any fields, even from alpha APIs.
Fields, definitely. If you by default clusters don't have this feature enabled, the endpoint isn't enabled, you cannot get from it. So the only clients making use of it are using it on alpha clusters, and they are using an alpha feature. If we change the type that returns, then those clients would break, which would mean you would have to upgrade them to a level that matched like the next alpha, or if it became beta, you'd have to upgrade those clients to match. I think that's inbound for what we claim for alpha. It's not actually that much worse than just switching to a different endpoint. Like those clients, they wouldn't get a deserialization error, they would just get a 404 not found error if we switch to a different endpoint. So I don't know that we actually make life better for those clients.
There's big skew between client version and server version in practice, right? So we can expect a lot of gets from older clients than like even kube control.
That are explicitly using this endpoint, sure. The kubectl debug command, is that still a plugin or is that built in?
It's a command. It's a built-in now. It's in beta, but it does more than just ephemeral containers.
Okay. I think we should fill out the notes from the discussion and kind of talk about the options that we saw, like lean on API machinery to figure out how to make an admission plugin, see all updates, even via sub-resources, which doesn't actually seem likely to happen anytime soon, or change the API, or make admission fetch pod context out of band with the examples of what the implications would be for things like Gatekeeper. And then in terms of investigation, like maybe see what it would look like to switch it to the full pod and verify we haven't missed any implications for old clients. Like we know they won't work, but is it bounded to just use of this feature, which was alpha at the time to them?
Okay, I'll look into those things. One final question. Are there any objections to the current API if there is no security context configurability?
If locking down pod capabilities becomes commonplace, doesn't that really diminish? Like Tim led with one of the key goals of this was to let your main pod containers run unprivileged and restricted, and then retain the ability to inject this.
Yeah. This is just to inform my understanding of what the requirements actually are.
Locking ourselves to an API that we know has difficulty in letting you flip the bits that make debug containers most useful seems like something we'll regret.
Yeah. Yep, that's reasonable. Okay, thanks everyone.
Thank you. All right, next up on our agenda, Micah, take it away.
Yeah, so I wanted to bring back to life a little bit the discussion on
private claims in projected tokens. It's an older issue Mike had originally opened, and there was discussion about like how do we do this? My understanding is basically that, okay, yes, we I guess technically could add some sort of private claims in an API, but issues are around, validation of those claims, structure of those claims, and what is, I guess it's a very open question about what that looks like, just because the API server is minting these tokens as sort of authoritative for external parties, and those external parties need to rely on and trust that those claims are accurate and correct. The reason why I'm very interested in this is like there's certain AWS features that would tie really well into this. AWS supports basically adding what we call session tags. So when you assume a role, and you can use a Kubernetes token to assume an AWS role, those tags can get propagated as context into your role session. So I can write AWS policy to say, if this was supported, to say, this role session can only write to this S3 bucket where the path prefix is the pod name, or the path prefix is the namespace name, or whatever we shove in this session context. One other solution that I thought about, kind of in addition to the discussion here, was could this be folded into the proposed external signing API? That does limit the sort of usability of private claims, but it does let an external signer sort of determine whatever structure or claims that they want. And it's the external signer at the end of the day creating this token. So they are sort of the authoritative place to say what claims are in the token. It gets it out of the Kubernetes API, which is less flexible for Kubernetes API consumers. But if you want to write your own, run your own external signer, you can add whatever claims you want there. Yeah, I guess I'd kind of like people who are part of this previous discussion I'm curious about your thoughts if that approach seems feasible, if the sort of existing problems, I mean, they still stand, but is there a way we can work around those, just because Kubernetes doesn't do delegation well of these requests? Yeah.
Yeah, I think this was one of the features, possible features that motivated going with a generic token signing, or going with an API structure specific to token signing versus doing like a generic signing API, which I know is discussed in the KEP. Yeah, I think that there are valuable use cases for this. I also think that just delegating to external signer is kind of the most flexible escape hatch. I'm not super worried about the barrier because hopefully I suspect that people who have use cases for this are pretty deep in the weeds already. I think the one thing that I want to be careful about is preserving claims that we want to make consistent or make part of conformance. But other than that, I think assuming we can get the external signing kept in, this seems like a very doable addition.
Yeah, Mo, you brought up I guess sort of a concern there. Is that Do you have more thoughts on your concern?
Yeah, I mean, to me, it's very strange to build an API that is effectively out of reach for all but the most advanced users, right? Like I can use token requests today. You know, I can attach my service account tokens to the pods and secret as anyone would expect, and you know that stuff is funneled through to the Kubernetes API as I would expect. Like this bar seems incredibly high, right? I don't know. I don't think it's necessarily that strange to want to inject some extra data. Right? It is the other bit there is also like, because as you mentioned, Micah, that this is trusted, right? Like anything you get from the Kube API server, you're going to assume it's valid because that's like the point, right? And I would feel kind of strange, like imagine like a sub map within the object that was literally like untrusted underscore user data or something like that, right? Like, why is there untrusted data in my signed jot? Like, isn't the point that all the data is trusted? It reminds me of the email verified claim in OIDC. Like, to me, it's like nonsensical. Like, I trust my OIDC provider. So either give me a verified email or don't give me any data. Like, you go verified, please. That's why I have you as my ID provider. So I don't know, it doesn't feel right to me to do it sort of in this regard. Like if I think about like the closest extension point we have to like the external signer today that already is there is the KMS code, right? And for the most part, the KMS code can't do anything that fancy, right? It just encrypts a data encryption key and hands it back to you, right? But it can't do much else, right? It doesn't even control the encryption itself, right? The API server actually does the final encryption. It's just the API server is handing you the key that it used and asking you to give it an encrypted copy back so that way it can get it back, right? But it's like a purposely limited API to both limit the surface area of the external entity that's attached to the API server, but also to retain all the control within the API server.
I can't tell if you are arguing that we should find a different way to implement or to extend the claims in the JOT that is like not tied to command line flags of the API server, or whether you want a separate command line flag configured extension for this, or whether you think that we shouldn't do this.
I'm more saying that I have not heard a proposed solution that makes me feel comfortable about the addition. Not that I don't think I'm against a feature. It sounds useful. I haven't necessarily heard an implementation that I would think was broadly useful and understandable and not completely out of reach of like normal-ish users.
Yeah, if I recall correctly, I think Clayton had a crazy idea about using an admission review for this.
That sounds like Clayton.
But I can't. I'd have to dig it up. Can't remember.
No, that was me.
Oh, it was CJ.
That was you. Yeah.
So the idea would be that you inline an admission plugin could intercept somehow and inject extra claims, and then we would just happily sign them on behalf of said admission plugin.
Yeah. Some policy. Maybe we'd allow some. Maybe we do the like enclose them in a known, not necessarily fully trusted block. It was a straw man to start discussion.
The difficulty there too is in structure, right? Like this is going to be serialized into the token, but it could be arbitrary structure from the claims.
I mean, the thing that can sign your tokens is as trusted as things go. So
I still think it's at the same level as how much you trust KMS, right? You're not telling KMS, here's some data, encrypt it for me and give it back to me. you're handing it the key that you used for encryption, right? In this regard, you're saying, here's some claims. I would really like them. I would like these signed. Thank you. But I control the data I sent to you. Right?
I think the thing is that the difference is KMS plugin does not know what the ciphertext is. The thing that is supporting the signing API can feel free to sign random service ground tokens out of band. They're consistent in structure. So I see the thing that can do the signing as very, very root if we're considering whether this is like a new vector for consideration in our threat model, then I would argue probably not.
Well, it's not as long as the input to it is not under user control. Like if what Mo is saying is like if we open it up to something under user control or API surfaced, or like, then I think it is increasing the threat model because you're assuming that the right things are in place to make sure that bad values don't get fed to the signer to stamp out.
Yeah, I agree. I agree with that. I don't think that. I don't know, Micah. What were you going to put in there, and what is the source of what you're going to put in there?
Yeah, the information that I really minimally care about and would want in there is basically what's already in the Kubernetes claims, but just in a different structure under a different namespace. Like there's the AWS docs have like I think it's aws.amazon.com/tags, and it's a.
So Micah, if I'm understanding it, you don't actually want new data. You just want to smudge the existing data into a different spot so like AWS can actually parse it already.
The only new data would be an identifier for the cluster.
Okay. So as a thought exercise, if you step back and say you control the signer, right? So you have the ability to sign JOTs that look exactly like service account tokens with basically arbitrary claims, like out of band, you can do this, right? Could you not go ahead and just build an aggregated API that had the exact structure that you want, right? Had the exact validation, whatever, right? Like it would be a different token request API that let you do exactly what you want, emit a token exactly in the shape that you want. And then,
but then you don't get it. You don't get token volumes and whatnot.
Yeah, the usefulness is because of the token volumes.
I mean, yes, I guess you would need like a custom CSI plugin to do the mounting aspect and all that stuff. I was mostly just thinking about the idea is if you're saying that, hey, I control the signer, I just, I want to, and I can go sign stuff if I want. It's true, and thus you could also sign it in the format that you need it. You just need to present an API to the actors that care.
Well, I think the goal is to make it so that the Kubernetes credentials in this cluster can be used this way. And to do that, it has to be the token request API, not just another equivalent API.
Okay. I meant that as a thought exercise, like how far could you take it if you just used your sort of like elevated access in the cluster and the ability to have aggregated APIs to sort of try.
Yeah, the other benefit of like using token request is that I think that like node authorizer you get that sort of for free, right? I guess maybe CSI gives you might give you that restriction too, but yeah, you don't have to. You know that the kubelet can only request tokens for pods that are on that node.
CJ asked a question in chat for why does it break token volumes? The like kubelet and stuff wouldn't know to use this API to like
Oh, you're talking about the separate API. I thought you were talking about the make your signer like add a little extra flavor.
No, so that would be abstracted behind the API server's API, so it would just work.
Yeah, that at least seems like the more correct model for provider wants to add stuff to make things work better with providers' other services, as opposed to workload or other sub piece of infrastructure wants to request things that may or may not be fully trusted by the API server itself. Like here we're saying, yeah, root on the API server is gonna switcheroo some claims and like copy them into a different block. And you're gonna get special tokens when you're running on this provider.
So would something like if the token request API, if that was extended in a way where I guess maybe inline you could request stuff, I don't know, some extra claims or whatever, could we somehow safely tie that to some kind of authorization or admission check, and thus like by default, no actor in the cluster other than cluster admin would be able to make that request because no one would have the correct permissions to do so?
I know we're like out of time right now. I think custom claims in these tokens almost always tie to systems outside the cluster. And so even cluster admin level access, I would not expect to be sufficient to inject arbitrary claims into tokens. Like if I'm cluster admin on my toy development on my toy cluster, but I can request a custom claim that gets like me privileges in some other system, that seems like just asking for like scope escalations.
Yeah, can we divide it into two cases where like one is the provider that owns the signer gets to do some subset that they're comfortable with. The other use case is kind of something wants to request some claims. We're not going to fully trust it. Could we make that work with they go in a different block and they can't be arbitrary. It's like well communicated that they're not quite trusted all the way.
I would want to see much more like specific use cases around I want some claims for some reason. Like
wasn't one like
appeals to me, but
I'm getting authenticated to by a pod with a label of some sort. That was a link in the original issue. Feels weird, but
yeah, maybe we should bump this and mull it over offline or in the next SIG meeting.
I'm happy to pick this up next SIG.
Right. Thanks, everyone.
Okay.